Hi, John from IDS here. Today I'm going to be taking a quick look at how you can use the GoDirect Force Sensor to investigate simple harmonic motion, in this case in the context of an A-level class. I'm going to be using my iPad to connect to the GoDirect Force Sensor, but you could use any mobile device or indeed any computer. For the setup, we've got the GoDirect Force Sensor connected to a retort stand, and suspended from that is a mass spring system, and I've chosen a low value of spring constant and a relatively high value of mass for this. To connect to the iPad, press the power button once and then open the Graphical Analysis app. Choose Sensor Data Collection from the menu, and your device name should appear on the screen. Tap on the device name, and then once it's connected, select Done. Before we start taking data, there are a couple of settings that I would recommend changing. In the bottom left of the screen, you can see a box that says Mode Time-Based Rate in it. If we tap on this, it is the data collection settings, and I'm going to change the sample rate from 50 to 200 samples a second for this particular experiment. And I'm also going to change the end collection time from 5 seconds up to 30 seconds so that we collect ample data to analyse, and press Done. And one other thing I would recommend changing for this experiment is the zero on the force sensor. So if we set zero at equilibrium position by tapping in the box that says force on the bottom right of your screen and tapping on zero, we're now measuring zero force at equilibrium. So now I can collect some data. First of all, displace the mass by a few centimeters and release. Make sure you've got a nice even oscillation, and then tap collect. And the data will now be collected over 30 seconds. Once the data is collected, we can do some analysis. I'm going to look at the time period of the system. First of all, we'll improve the resolution of the graph by zooming in. We can do this by tapping the magnifying glass at the bottom left of the screen. Alternatively, you can pinch on the screen to zoom in like so. To measure the time, tap and drag on the screen and select an area where you have 10 peaks and view statistics. We now have the range for the x-axis shown in the statistics box, and we can see that the delta x value, the total time, is 9.145 seconds. So divide that by 10 and we get 0.9145 seconds for the time period of the oscillation. For further ideas and analysis for this experiment and many others, please do drop us a line and we'll be in touch. And thanks for watching.